In today's video, we're going to look at section 1-8, the number systems. So the number systems incorporate the numbers that we deal with in math and in everyday life. But they're set up in different sets to help us identify where they belong and what they are. So let's get started. So when you were younger, you started with the counting numbers. And another number for counting numbers you'll hear called natural numbers, and the name counting numbers tells you what they are. It's where you started with numbers when you were younger: 1, 2, 3, 4, 5, 6, and so on. And then you got a little bit older and you learned some arithmetic, and that's when we had to start including the number 0, and that's what creates whole numbers. So whole numbers are different than counting numbers, obviously, because of the 0. The 0 adds value to all our numbers. So first you learned them in order, just 1, 2, 3, 4, but then you added 0 at the beginning and said, well, now you have value to it, because without 0, nothing has value. We have that because when you start your addition and subtraction, 3 minus 3, well, you need an answer for that. So that would be 0. Okay, so that's where the whole numbers become whole numbers. Okay, and then so think of these as rushing nesting dolls. All counting numbers are whole numbers, but not all whole numbers are counting numbers, because 0 is not a counting number. So then we're going to add another layer. We're going to add another Russian nesting doll, and that's where we add integers. This is where we include the negative whole numbers. So we have all the way from negative infinite to negative 3, negative 2, negative 1, 0, 1, 2, 3, and so on, all the way to infinite. So now all counting numbers are integers. All whole numbers are integers. But not all integers are whole numbers, because negative whole numbers are not whole numbers. Okay? So we just keep expanding. And then we move on and we add the rational numbers. Okay? Rational numbers are any number that can be written as a fraction. So I got a mistake here. Let's change that. I don't know how that one got in there. There we go. That's better. Okay? So any number that can be written as a fraction. So a fraction is obviously a fraction, so that's a rational number. And then we have like a whole number. A whole number is a fraction. It can be written as like 1 over 1, 3 over 1, negative 5 over 1. Those are still fractions. Some decimals can be written as fractions. 0.5 can be rewritten as 1/2. So those are all rational numbers, any number that can be written as a fraction. And then it incorporates everything to all real numbers. Okay? So now there's part missing that's going to come up on the next slide. As you notice, I ran out of room, so I got rid of the counting numbers part, but you know it's in there. But real numbers are any number you can think of. So that is the numbers, also the decimals that cannot be written as fraction. And I'm going to include it here in a second. It's going to be on the next slide. So no matter what number you can think of, you have a real number. So the one we're missing is numbers in between the rational numbers is what we call irrational numbers. Okay? Irrational numbers are the exact opposite of rational numbers. Rational numbers can be written as fractions. Irrational numbers cannot. So an example of an irrational number would be pi, or the letter E, or the square root of 7. Okay? And a lot of square root numbers are irrational numbers, except for when you have perfect squares. So like 1, 4, 9, 16, 25, the square of those are whole numbers. Okay? So we're going to start looking at this. So name the set or sets of numbers to which each real number belongs. So obviously it's a real number. So 5 over 22, that is a fraction. So is it rational or is it irrational? It is rational. So that's where we always start. You always start with the rational or irrational, and then you move on. Is it a whole number type? Well, no, it's not even a whole number. It's a fraction. So it's not an integer. It's not a whole number. It's not a counting number. So that's it. Square root of 81. Well, the square root of 81 is actually 9. Well, 9 can be written as a fraction, so it is rational. Okay, well, 9 is a whole number, and it's a positive or negative whole number, so it is an integer. It is also a positive whole number, so that means it's a whole number. And it is also a counting number, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is a counting number. All right, so there we go. Square root of 56. So the square root of 56, it's not a perfect square. The perfect squares are 49 and then 64. So even if I grab my calculator, I get 7.5 or so, but that decimal keeps going on. So I can't write it as a fraction, so it is irrational. And if it's irrational, that's all it is. There's nothing else to it. Okay? So now the closure property, this is a little bit trickier. This is a property that says if I apply a arithmetic operation to two numbers in a certain set, do I get out of that set? So I can stay within the set. So if I take two whole numbers, like 2 and 0, and apply operation to them, do I leave the circle or do I stay within the circle? Okay, so we're going to go through a couple examples because it's a little bit trickier. Okay, so whole numbers under multiplication. So any whole numbers, those are, remember, whole numbers are 0, 1, 2, 3, dot, dot, dot. If I take any two numbers of whole numbers and multiply them together, will I stay within the whole number set, or will I get a negative number? Will I get a fraction or whatever? And if you think about it, I can pick any two numbers. For example, 3 times 0. I get 0. That's a whole number. And you can try it with any whole number. You will get a whole number. So if that's the case, that means it is closed. Okay. The next one, whole numbers under subtraction. So this one's a little bit different. Remember, we got 0, 1, 2, 3, and so on. So it works in most cases, but like 4 minus 3 is 1. So yeah, it works. But if I take 3 minus 4, I get negative 1. That's an integer. So I went outside of the whole number circle that was on the previous page. So in that situation, it means it is not closed. Okay, so integers under division. So integers under division, again, so negative 3, dot, 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 positive 3, and so on. Okay, so positive, negative whole numbers. Under division, you know, if I say negative 3 divided by 3, that's negative 1. That is an integer. But what if I did 1 divided by 2? That's 0.5. That's a rational number. I'm going, again, outside of the integers bubble, so it is not closed. Okay, and one more. The integers under addition. So if I take any two integers, negative 4 plus 5, I get a positive 1. 1 is an integer. No matter what numbers I pick, I'm going to get an integer. I'm not going to get a decimal, so that is closed. Okay, so this is just a basic graph, and how, you know, we've done this in the past. So graphing is quite simple. We just want to place a point and mark where it is. Now notice negative numbers run backwards. So graph each set. So I'm going to pick my spot 0. Now if we notice we want to graph negative 4/3, negative 1/3, 2/3, 5/3, these are by thirds. So I'm going to go by threes and make a negative 1, 1, 2, 3, negative 2, negative 3, and I'm going to make sure I can get my thirds in there. That way I know what I'm getting. So negative 4/3, that's negative 1 and 1/3. So my first point is right there. Negative 1/3, 2/3, and 5/3. There we go. Then the next one, x is greater than 2. So greater than symbol. So I'm just going to put a 0 here. So negative 2 is right here. I have a greater than symbol, so it's an open circle, and I follow the arrow. When A is less than or equal to 4.5. So I'm going to mark, let's see, 0 right here. 1, 2, 3, 4, 5. I got 4, so I'm going to put a dot right in the middle. And it's going to be a closed circle, so up and to the left. And that easy. That's graphing. Okay. I know it's a long video. Bear with us. We're almost to the end. Next, square roots. So square roots indicate what number multiplied by itself will give you the answer. So if you see no symbol in front of the square root symbol, that means you want the positive. If you see, you want the positive answer. Oh, posite. That is incorrect. That's weird. A positive number. If you have a negative symbol up front, you want the negative. And then if you have this thing, we can say plus minus, you want both. Okay, so to find the negative square root of 49 over 256. So that symbol out front tells me, my answer will be negative. And then the square root of 49 is 7, and the square root of 256 is 16. So my answer is negative 7 over 16. Okay, the next one. Square root of 4 over 21, there's no symbol in front. So we have a positive, so square root of 4 is 2. Square root of 121 is 11. So my answer is 2 11ths. The next one, plus minus the square root of 1.69. Well, plus minus, that tells me I want both, so I'm going to write plus minus out front. And then let's grab our calculator. Square root of 1.69 is 1.3. And there you go. Okay, so replace each with less than, greater than, or equal to. So I'm just grabbing my calculator because 19 is not a perfect square. So the square root of 19 is approximately 4.36. Well, that's obviously greater than 3.8 repeating. So it's that easy. 7.2 repeating, and 52 is also not a perfect square. So I'm going to grab my calculator, and I get 7.21. Well, 7.21 is less than 7.2 repeating. There we go. Okay. Again, really quick, square root of 5 is 2.24. That is less than 2.6 repeating, so I'm going to write 2 2/3. And then 8 divided by 9 is also 8.8 repeating, so those are equal. Okay, so I'm just using my calculator to double check. Okay, and the last one, we just want to order. So I know my negatives are my smallest, so I'm just going to get some numbers. Square root of 7 is, so I have negative 2.65. 53 divided by negative 20. Oh, we have negative 2.65, so I need the other one even more exact. So this is negative 2.645. All right. And then we have 2.6363 and so on. And then the last one, 8 divided by 3 would be 2.666 and so on. So now I want to order these smallest to biggest. So I have negative 53 over 20, then the negative square root of 7, and then 2.63 repeating, and then finally 8 over 3. Okay, so we're just using our calculator, checking the value of numbers, and trying to figure out where everything goes.